My name is Michael White. Welcome to another of the CASA webinar series on uncontrolled aerodromes. As you can see, today we'll be focusing on situational awareness pretty much in the circuit and generally, but we'll be looking at how we go about building your situational awareness while operating in a busy terminal area. This is the third of the webinar series on uncontrolled aerodromes, and the webinar will be recorded as it is. Generally speaking, make sure you turn off your microphones and cameras, please, if you wouldn't mind doing that. There'll be opportunity at the end of the seminar to ask questions, and you can either ask a question generally, or you can direct that question at a panel, one of our specialist panel members, if you so choose to do that. Alternatively, you can type in a question as the presentation progresses into the chat column by left clicking on the chat bubble at the top of your screen, and I have a aviation safety advisor from the Brisbane office monitoring that, and he'll be able to answer your questions as we progress through the presentation this morning, or just respond to any comment that you might have there. So that's the idea, is in terms of the Q&A for the session this morning. Then we'll conclude, and Landy, our coordinator, also in the Brisbane office, will change the settings and teams to so you're able to turn your microphones on and ask those questions in the short Q&A session that we'll have at the end of the seminar this morning. So the recording will be available on the CASA Pilot Safety Hub that has been recently introduced by CASA, and you'll find it there, of course, under the general heading of uncontrolled operations at uncontrolled aerodromes, and it'll take around about 24 hours, if not that, to get that there and to be available for you to have a look at your leisure. So that's it in terms of the housekeeping this morning. If we go on to the introduction shortly, as we said, this is a series of 4 webinars on operations at uncontrolled aerodromes, and so far to date we've had a look at radio broadcasting, operating in the circuit at an uncontrolled aerodrome. We've had a look at standard arrivals, standard departures, and when we might broadcast the standard broadcasts that have been required, standard phraseologies, all of that type of those defences that are in place to help us manage safety at aerodromes that are not controlled by ATC as such. This is the third, as I've mentioned before. This will focus on building situational awareness, and the one next Tuesday will be the last of the series of the uncontrolled aerodromes, and that will look at once you've built SA, maybe the signs that you'll see in terms of a degrading of that SA, and some tips about how to go about preventing that from happening. So that'll be the last in the series of 4 in this uncontrolled aerodrome series of webinars. The next topic to be dealt with by webinars to have a look out for is weather and forecasting, and my colleague in Brisbane will be doing those across November and into early December. So introducing the team this morning, I have myself, Michael White's my name. I'm an aviation safety advisor, currently the team leader for CASA. I work out of the Melbourne CASA office in Docklands. We have Neil Boag with us. Neil is the flight standards manager at RMIT University Flight School at Point Cook Aerodrome. We have Chris Gill. Chris is his first time with us to be our one of our specialists for the webinars. Chris is the Aviation Support Coordinator with RAAus, and Chris has a commercial pilot's license and has a Grade 1 training endorsement issued, of course, by CASA, and has some experience at some different major flight schools around Victoria as a flight instructor. We have Stefan Alman, who's joining us again this morning. Stefan's an aviation support, is a safety manager and flight instructor at Moorabbin Aviation Services at the Moorabbin campus. So welcome again, Stefan. And we have Rob Whittle, and Rob is our aviation safety advisor in the Brisbane office, and Rob takes care mostly of almost, I think, if not all of Queensland, and Rob is our operational support for the webinar this morning, and Rob will be the person who's answering you in terms of your questions, should you have any that have been posted into the chat, or just responding to your comments there. So that's the team with us this morning. So without further delay, we'll get on with having a look at our presentation this morning. So thanks for joining us, and I hope you enjoy what we have for you this morning. So starting out, I thought I would mention some statistics that are centered around human factors, and they come from different parts of the world. Firstly, they're and they're quite interesting. And just one slide on statistics, I promise you. And some of those statistics are interesting in that Micah Ensley in 1995. Micah is was the psychologist who developed the situational awareness model, the 3 levels that we'll have a look at as a part of the presentation this morning. And she's come to the conclusion that 88% of occurrences involving human error are attributed to some sort of problems with situational awareness in major air transport operations. So it's sort of an interesting statistic there that we need to keep in mind. Also, the ATSB, closer to home, has come to the conclusion that 85% of incident reports that they receive from industry mention some sort of loss of situational awareness, which was a part of the build up to the incident that had occurred. And lastly, from the FAA in the US, they've seen that poor situational awareness can lead to things like spatial disorientation. And spatial disorientation doesn't necessarily mean that you've entered cloud and you've lost control of your aircraft, for example. It could just mean that you're a little disoriented or confused about the situation that might be happening around you. And generally that's a result of say, poor situational awareness. So either a problem with developing it, or a problem with losing or degrading the SA over a period of time once you've built that. So so there's some interesting statistics there that we've seen from different parts of the world in terms of building situational awareness. So what I might do is I might put a couple of questions to our panel just based on this, and might start with Stefan, if I could. Stefan, do you find that students' performance, generally speaking, is created by a failure to build SA?
Yeah, can you guys hear me? Hello, everyone.
Yep, loud and clear, thanks.
Yeah, so yeah, it's quite a vague, or not vague, sorry, it's quite a broad term, loss of situational awareness. And I find, yeah, as the stats show, it's very similar to our organisation here. The majority of our incidents are either causal factors that lead to a loss of situational awareness, or a loss of situational awareness that leads to more incidents down the line. Yeah, 100%. It's difficult to legislate, I guess, for situational awareness because it's such a subjective term. It comes down from person to person. Quite often you'll get a student with a decent amount of situational awareness from flight 1, or you can get students with hundreds of hours who still struggle with situational awareness. But yeah, looking at all our incident stats as well, I'd say similar to those stats there, I'd say about 90% of them is either due to a loss of situational awareness or causal factors that create a loss of situational awareness as well.
Yeah, thanks, Stefan. It's a good point. Just because a pilot might be experienced, it doesn't necessarily mean that they're going to be able to maintain a good level of situational awareness once it's developed. I might go to Neil. And Neil, do you find that, say, licensed pilots, you know, those that have a reasonable amount of experience, say during a flight review, for example, do they have difficulties with developing SA as such?
Again, it's a fairly broad response to that. You'll find that you'll get licensed pilots that are not particularly current, that may get a little bit behind the 8 ball because they're not particularly well prepared for the flight. And you'll get to the other extreme where you find that you'll get someone who's a recent PPL holder or APL holder, and they well prepared and more current, and you'll find that you'll get a better outcome from that. So there's not necessarily a direct correlation between experience. Some more experienced pilots can be more blasé about it's just a circuit entry or whatever it might be, which can lead to a false sense of security. So a little bit variable, but again, it comes back to the preparation and regardless of your experience.
Yeah, thanks, Neil. Yeah, it's a good point. I think you've mentioned being prepared, and as we'll see a little bit later on in the presentation, preparation is quite an important thing to do prior to a flight, because it impacts well, at least impacts one particular level, say level 2 in the SA model that Micah Ainsley developed, and that is comprehension. So adding value or meaning to the things that you notice going on around you. And if you haven't prepared adequately, you'll have difficulty doing that in terms of you know, your level of knowledge as you've prepared for that particular flight. I might go to Chris. Chris, do you find that in your experience as a flight instructor that you sometimes need to direct a student's or a pilot's attention to a particular task or area to help them develop that SA process, if you like?
Yes, certainly, especially in the initial stages of training. The student can get very easily distracted and focused on, you know, straightforward things like just, you know, focusing on the instruments rather than looking out. And we tend to continue to train them and get them out, get their eyes looking outside. And then, of course, we take the students and then we move them on to navigational exercises. And again, there's a lot of cockpit management going on, you know, where they've got to check the IRSA, check the frequencies, and those are all big distractors. So, you know, even when we see the students coming back into the circuit, you know, if they haven't prepared enough in time or they feel behind the aircraft, they're very easily distracted. And quite often we have to direct their attention and say, hey, you need to stop that task. You need to keep a good lookout because, you know, the airport's coming up and, you know, you've got to be prepared to make sure that we've got situational awareness built in advance. And so, yeah, it certainly is a big issue, especially with workload increasing for students as they mature as pilots. Obviously, that decreases, and the tunnel vision is not so relevant.
Yeah, thanks, Chris. A couple of points there as well. You know, you mentioned focus and workload, and there can be workload is and can be a barrier to developing a good level of situational awareness, as we'll see a little bit later on. And I like your comment about you know, directing their attention to focus on other things to try and guard against that problem of distraction, which can tend to degrade SA also over a period of time. So some good points there. So what I'd like to do is just move on to the next slide, and I'll introduce the Swiss cheese model to you. I'm sure a lot of you, if not all of you, have seen the James Reason Swiss cheese model, and the Swiss cheese model was coined by one of by one of James Reason's PhD students. He didn't name it that himself, as one of his PhD students said, this looks like, or could be thought about like a few different layers of cheese with holes in them that represent different layers of a complex system, and those holes are the imperfections in each of the layers of a system, because no system is perfect, and as you can see there, each layer can be represented by a defense, if you like, to guard against the problem of a bad outcome, particularly around the circuit area, a busy circuit area. So we start off with planning, which we mentioned a little bit earlier on. So that preparation is quite important, regardless of what you're doing. It might be an hour of circuits. It could be a 5-hour cross-country flight for business, or an air transport operation as such. But we can still use this regardless of our level of operation and our experience and our level of qualifications as a pilot, because it's universally applicable. So we start with the planning of the flight, and then we can introduce things like standard procedures, and we've had a look at those over the last 2 previous webinars, where we've looked at standard phraseologies, a standard broadcast in a standard order. That is a defence. So standard circuit entries, standard circuit departures, and that type of thing. They're all standard procedures that we've put in place that provides us with a layer of defence against a poor outcome or a bad outcome. And then we have things like listening out on the appropriate frequency, so actively monitoring the frequency that we're using at the time to listen for other broadcasts, to work out the intention and position, location, etc. of the other traffic around us. We have a level of the cheese defence there, where we use radio broadcasting, for example, which is the alerting part of the alerted, see and avoid, and of course lookout, the sight and avoid procedure that we use is also very important, and provides us with a level or a layer of defence. And when we put all of those layers together, we build up a reasonable level of defence against a poor outcome, which might be a mid-air collision, for example, in a busy circuit area. And I might add that it doesn't need to be busy. I mean, all you need are 2 aircraft to come together at the wrong time to provide you with a bad outcome. Now, as it says there, you get a window of opportunity that opens up, and it's not always there. The window of opportunity opens up when all of these imperfections in the different layers of the Swiss cheese model tend to line up, and you get this clear shot or this opportunity of a poor outcome or a bad outcome that occurs. But hopefully the idea is that one of these layers of defence that we've got in place will prevent that window of opportunity from opening up, to provide us with a good level of safety when we're operating around an uncontrolled aerodrome. And the other thing to think about is, just because the window of opportunity for a poor outcome opens, it doesn't necessarily mean that you'll have a poor outcome, but that there's just an opportunity for something to occur if the different layers of defence break down. That's the idea of the Swiss cheese model. I might, if I can go back to you, Neil, do you see examples of these layers of defence breaking down specifically during training, or any other operation for that matter? Is it sort of clear where they break down?
I think in the early stages of training, the students are suffering from workload overload, essentially, and they tend to become more focused on what's going on within their own aircraft, and lose that situational awareness. And the way I try to explain situational awareness to a student is, you have to play chess in 3 dimensions. So it's a 3-dimensional chess game, And all of these things that we use, the standard procedures, the listen out, the broadcast, is to try and take as many variables and eliminate that part that we don't quite understand. So if we're doing things that are standard, we know where to look. If we make standard broadcasts, that helps other people look where we would be, and so on and so forth. But when they start to get a little bit behind the aeroplane, if they make a mistake and that rattles them, they then sometimes struggle to maintain that SA that they've built, or they lose it entirely, and quite often with that comes a loss of confidence in what they're doing. So yes, there are other things that will affect that.
Yeah, thanks, Neil. And we'll have a look at that a little bit later on in the presentation when we sort of take a look at the barriers that that are there that make it difficult for a pilot to develop that good level of SA, for example. So thanks, Stefan. To you, looking at it from the opposite point of view, do you see while you're flying other layers that are a part of this defence system preventing or stopping a bad outcome?
Yeah, so I mean, just going off what Neil said there, I think the main defense layer where the holes are probably biggest is the individual defenses, basically coming down to the individual themselves, the pilot, maintaining recency, being aware of his situation. But in terms of the barriers, which are really good if we use them well, is really I think the standard procedural defenses that are in place. So an example would be a student potentially going into Essendon for the first time, which is a controlled aerodrome, or going into a non-controlled aerodrome that they've never been to before, which has very specific procedures in place. The defences are in place already there in terms of what's on the IRSA, what's been established by CASA in terms of how we go into a non-controlled aerodrome, and then what's specific to that particular aerodrome in the IRSA in terms of how we are to enter that aerodrome. So that just means that we've got that defence in place where we can put everything down before we get into the aircraft, have a look at all these layers, these procedures, and plan accordingly, and put those defense layers in place and try and get those holes as small as possible. We know they're still there because it's going to come down to the individual to implement them properly. But if we line enough of those procedures up, then hopefully we've got enough defense layers to try and prevent those holes from occurring. So I'd say, yeah, the procedures that are in place, the standard procedures that are in place, like that first layer there, the Swiss cheese model.
Yeah, thanks, Stefan. Another way of looking at these diagrams, or another way that I've seen this illustrated, is each one of those different slices of the system generally or gently and slowly rotate. So you go through periods where you might have 2 or 3 holes that briefly line up for a short period of time, and then a situation changes and that they're no longer aligned, so you don't get that window opening up at the end of it, which I think is a good way to express or to illustrate this these levels of defence. So those slow moving discs, if you like, which represent those defences in the system that slowly rotate, and every now and again you can get 2 or 3 holes that are aligned for a brief period of time, which opens up a window of opportunity for something to occur. So I thought that was a really good way of looking at the way that the complex system works. Also on the slide, you might see there that we've got things like lights, transponder, ADSB, so those technological equipment that we have that also give us a form of defence as well. Chris, I might go to you. Do you see things like lights, transponder, ADSB, if equipped like that, that they also help as a defence measure, particularly in a busy circuit area, for example?
Yes, certainly. I guess going back to the days of old where we had halogen lights, people were very hesitant to use them because they only had a 15-hour lifespan. But with the increase in modern technology, with now LEDs coming forward, which are a lot brighter and they can be left on permanently, I certainly have a strong belief in the use of lights, and where appropriate, and you should always have your transponder on. But the ADSB and the ADSB feedback has made a big difference in helping build situational awareness although we have to be cautious not to overly focus on it. Remember, our primary way of see and avoid is still super important.
Yeah, I think that's a good point. Absolutely, there's sort of no substitute for maintaining a good vigilant lookout and employing some sort of standard scanning technique to help you sight and avoid other traffic there. So yes, some good points there, I think. I might also just add, just before we leave this particular slide, that that window of opportunity or the bad outcome, it doesn't necessarily have to be a collision. It could be quite a close near miss, which might provide a startling effect, and then pilots sort of over controlling the aircraft if you're a little bit quick going downwind, for example, and overstressing the airframe. So things like that can be a poor outcome from a degrading of SA in the circuit area, as an example. And these are only just some of the examples that we'll get in terms of defence measures in the system. It's been mentioned just before that things like the pilot experience is generally a good level of defence preparation. Those types of things as well contribute to a good, safe system that's defended well. So let's have a look at the, let's go on and have a look at the next slide. This is just an example of a specific defence that we've got in terms of operating at in a busy circuit, for example. So in this particular case, we've got aircraft at different speeds flying at different levels downwind. So we've got low performance aircraft with a maximum of 55 knots as a normal downwind speed at 500 feet, and then we move up to 1,000 feet where we've got, I guess, the majority of our traffic in general aviation between 55 and 150 knots indicated downwind. And then of course we've got the quicker, generally heavier traffic of at 1,500, and they fly that if they have a downwind speed in excess of 150 knots, which is sort of important to remember, because when you're flying into and out of an uncontrolled aerodrome with air transport operations, for example, Qantas, Virgin, Jetstar, Rex, whoever it might be, it's likely that their downwind leg will be at 1,500 feet. And this helps to segregate the traffic as you progress downwind. But of course, the issue is there that eventually you need to turn base and final approach, and this is generally where the problems might actually be occurring when you lose that, you know, general segregation of traffic as you coming around base. So Neil, I might ask you, do you find that pilots don't project ahead enough, say, you know, to assess conflicts around base leg and onto final approach, for example, given that they're, you know, vertically segregated as they're going downwind?
You're right. There is a bit of an issue with that, and there's an increasing number of RPT aircraft going to uncontrolled aerodromes at the moment, and I don't think a lot of pilots appreciate the speed difference between their aircraft and their own. And they don't project about how much space someone would need to fly a standard circuit. We talk about speed, but speed also equals how much space they need to make a standard circuit and still fly their normal profiles. And so they'll quite often turn where they would normally turn onto base, not realising that there's an aircraft of a higher performance that's turned a wider base out of necessity, and then putting them to a conflict to base and final. So yeah, it is something that people need to be much more aware of. We have a base up at Bendigo, and we have RPT aircraft coming in, and that's one thing we're very, very mindful of with the students up there, is to get them to appreciate how much extra space they'll need on the downwind leg, and therefore leading to a wider base, and that then has implications to where they may or may not be able to turn base.
Yeah, thanks. Some good points. Stefan, I might also go to you. Do you generally find that that some pilots don't consider that issue of performance parameter as it might apply, you know, between the different types of aircraft that are operating in the general vicinity, and they don't sort of build that into their SA as they're building it to the extent that they don't project ahead and take those performance characteristics into consideration.
Yeah, absolutely. It's one of the areas where I think particularly our low time student pilots, when we send them on first solo or second solo for their first solo operations, this is probably one of the areas where situational awareness does change with experience, because it's usually our first time solo student pilots that are so focused in the circuit on actually flying the aircraft and just maintaining correct spacing, maintaining the speed of their own aircraft, that they don't necessarily think of the traffic ahead of them or traffic that might be coming in from, calling inbound 10 nautical miles. So yeah, absolutely. And also, taking the environment into account with different aircraft. So we had a big issue here at Moorabbin, because we used to have a lot of Foxbats flying around when most of our students fly Piper Warriors quite a bit faster than the Foxbats, particularly on base and on final, where the wind really started to impact them, where they maintained a sufficient spacing on downwind, but they wouldn't think far enough ahead in terms of planning that spacing between themselves and the aircraft ahead on base and final. Absolutely. So trying to train them from very early on, basically from the point where they start to turn crosswind and downwind, having a think early on about what the spacing should be at that point to account for the spacing on final approach. And then, yeah, going into non-controlled aerodromes with RPT aircraft calling in 10 nautical miles. We know with our aircraft, it takes usually 5 to 6 minutes from calling in inbound 10 nautical miles to actually getting overhead. But then taking into account different types of aircraft might, be overhead within 3 minutes, depending on their performance parameters. So it goes back to knowing your types of aircraft as well, and then considering their performance based on where they are and what their speed's like. It's definitely one area that we have a lot of incidents in, and students tend to lose situational awareness in, for sure.
Yeah, thanks, Stefan. Chris, operating recreational type aircraft, there's quite a broad scope or spectrum of performance characteristics in recreational aviation. Do you find that sometimes recreational aircraft performance is a little bit misunderstood and not taken into account?
I think that's a bit of a yes/no type answer. I think initially RAA aircraft were very misunderstood. I think now, especially with a lot of RAA aircraft being able to be cross-registered, seeing them both on the RAA register or as a VH registered aircraft, people are certainly getting more aware of them and their performance characteristics. Bear in mind that most RAA aircraft will outperform a Cessna 150. Especially the model ones like the Slings and the Technams and stuff like that. So I think from that aspect, we do have a very big range. Obviously, we cover powered parachutes all the way through to Slings and stuff like that. So, but we generally see most of those lower performing aircraft flown out in uncontrolled aerospace rather than controlled airspace like Moorabbin, where you'd have the high performance aircraft. But there's certainly a vast range of performance aircraft that we cover, and I think they are relatively similar to most GA aircraft. So from a planning perspective, that does help.
Yeah, thanks, Chris. Let's have a look at the next slide, and this is a slide illustrating the standard circuit entry procedures that we use as a defence when we're operating at an uncontrolled aerodrome. So whilst we might have some type of vertical segregation flying downwind, for example, we've all got to at some point in time enter the circuit if we're arriving, and departing the circuit if we're leaving to go somewhere else. And of course, we mightn't necessarily have that vertical segregation of traffic whilst we're doing that. So these are the standard recommended ways to enter a circuit. I'm sure you've all seen these before. These diagrams are available in the VFR-G, the Visual Flight Guide, for example, and Part 91 will address these standard procedures to arrive and depart from an uncontrolled aerodrome as well. And one of the standard ways to do that is to overfly the aerodrome. prior to entering the circuit. So, Chris, I might go back to you again. In terms of building SA, there are some advantages to overflying an aerodrome as a standard way to enter a circuit. What would some of those advantages be for a pilot?
So it definitely builds more time. One of the biggest issues is that you need to build an SA picture, and time is definitely something that's super critical in doing that. By overflying the airfield, you get to assess who's in the circuit, where they are located, gives you more time to spot them, or to ask questions to other pilots. The other thing that's important is it gives you an opportunity to assess the airfield, how busy it is. Like here at Bendigo, you can see whether the RPT is moving or taxiing, and again, assessing the windsock to make sure that the most suitable runway has been used. So there's a number of benefits to overflying the field, and in fact, that's one of the things we encourage at all times to overfly, because it's that time-based scenario that is helping increase students' situational awareness dramatically.
Yeah, thanks, Chris. There are definitely some advantages by overflying. For example, as you've said, you buy a little bit more time. You get to assess the traffic, and also importantly, you get to assess the aerodrome in terms of the runway, the taxiway layout, and orientate your aircraft to the landing runway, which is a big issue in terms of situational awareness. I might go to Stefan now. One of the ways to enter a circuit, which isn't depicted on this diagram, for example, is to do it via a straight-in approach, which is strictly speaking allowable. It's not against the law. The regulations permit it. It's just not a standard way of entering a particular circuit. What are the disadvantages, do you think, Stefan, of that there would be in terms of building SA to doing a straight-in approach?
Well, just continuing really what Chris said, it's basically the only reason we teach straight-in approaches, usually at commercial level, is it allows you to save time, and by doing that you might save a little bit of fuel. You might also save money for the company that you work for. So that's really the main reason we might teach them to do straight-in approaches at commercial level. But just like Chris said, we usually, to be safer and to give yourself more time, we always teach at PPL level or RPL level to do overhead approaches, basically, to assess the field. So by doing straight in, basically you give yourself far less time to actually plan your approach. You might have a particular picture in your head of how you're actually going to approach the field on final, and hopefully without anything going wrong, land the aircraft. But then another pilot might be overflying at the same time, joining from a different direction. Maybe there's another pilot in the circuit that's not too sure what they are doing. And it just gives you far less time to come up with a new plan if you're on straight approach. The only time you might do it is if there's not a lot of traffic in the circuit already. But we always teach if there's one or two aircraft in the circuit, it's always going to be safer to do an overhead approach, because it's very difficult to project where certain aircraft are going to be in the circuit once you actually get to that 3-2 nautical mile boundary. And it just gives you far less time to actually plan what you're going to do thereafter, should the situation not unfold like you planned it to.
Yeah, I think that the last point is a good point. You might very well have a TAF, for example, and you might know what the surface wind is doing and what runway would be used as the duty runway. But of course, forecasts are not always 100% accurate. So, overflying the aerodrome, for example, you get a good look at the windsocks, and you can compare that against what you might have expected the surface wind to be doing. And from that point of view, you might need to make a decision about the runway that you plan to at least land on from a forecast point of view. Yes, air transport operators like to do straight-in approaches. There are advantages for them to be able to do that. As we've seen in previous webinars, some of those aircraft are difficult to see out of, like the Q-Link Q400s, the Saabs, for example, and the bigger aircraft, the 737s and the Airbuses that might operate into and out of places like Mildura, Ballina on the northern coast of New South Wales. They can be difficult to see out of, and Australian approach does provide them with the advantage that all of the traffic that's likely to conflict with them is generally going to be in front of them if they're established on final approach for the landing runway. So they do like doing those types of approach. But of course, if you're doing an Australian approach, the thing to remember is you need to give way to all of the other traffic that's established in the circuit at that particular aerodrome. So thanks for the comment on that stuff. Here's another slide. This is just depicting or illustrating the different standard ways to depart a particular circuit. And the thing to sort of note here is that upwind off the departing runway, if you are planning on doing a turn contrary to the circuit direction, so if it's a left circuit, of course, and you'd like to do a right turn after departing, you've got to be clear of the circuit traffic to be able to, well clear to be able to do that. And the thing to take into consideration are is the performance of the other traffic that might be operating in that particular circuit, for example. So if you have a air transport type aircraft that's operating, they'll be flying at 1,500 feet downwind. You'd need to at least go to 2,000 feet upwind prior to turning in the opposite direction of the particular circuit. So this is just another way in terms of providing a defence, a standard defence, in terms of the procedures that we use to provide you with that level of protection when you're departing a busy circuit area. Really, I just wanted to say on that. What I'd like to do now is move on to this particular slide, which depicts Micah Ensley's model of situational awareness. Now, Micah Ensley came up with this when she was, I think, chief scientist for the United States Air Force, the USAF, and she developed this probably for USAF operations, and she came up with 3 levels of situational awareness that people in safety critical industries like aviation, for example, need to progress through to be able to build a good level of SA. And as you can see there, there are those 3 levels: perception, level 1, building to comprehension to level 2, and then to projection or projecting ahead, which is the 3rd level of situational awareness. Prior to doing that, you need some sort of preparation and planning, as you can see there at the beginning of the diagram. And when you progress through those particular levels of situational awareness development, out the end pops the decisions that we need to make, those safety critical decisions as a pilot that we make to maintain the safety of our particular operation. Just before I go on, at the top there of the diagram, you can see the tools or the methods that we might have that are available to us to help us build that level of SA. And down the bottom here within the diagram, you can see some of the barriers that might get in our way while we're trying to progress through those 3 levels of situational awareness development. So that's from Ensley back in 1988, and generally speaking around the world up to this point in time, that's been accepted as the one of the better ways to develop a good level of SA and to maintain it over a period of time. So I might go to Neil. What do you see as are the most of the problems with low time pilots when they're developing SA at an uncontrolled aerodrome? Do you see them having difficulties progressing through these levels? So do they miss things? They don't notice them? Do they have trouble understanding what's occurring around them, even if they've seen it? And that would more than likely then lead to a problem, as we've spoken about before, with projecting ahead and coming to those decisions that need to be made. Is that a fair assessment, you think?
I think it's very fair. The biggest issue I find with students and low time pilots is really haven't given enough time and consideration to the planning aspect. So what you're trying to eliminate when you get into a circuit is the variables. So well before you enter the circuit, you should have a good understanding of your expectations for that circuit entry, what it should look like, by listening out well and truly before you get to the circuit, what is going on within that circuit, and building that SA as much as you can prior to getting to the circuit. If you've got an AWIS, you're able to determine a runway. By listening out early, you're able to hear what traffic is in there. The closer you get to the aerodrome, the more you're looking for aircraft, both radio and non-radio aircraft at some of the country aerodromes. There's aircraft operating there that don't necessarily have a radio, and some might more or less not use it. And so all of those things come into your planning, and I'm not sure that a lot of places teach that particularly well, and that's something I think all flying schools should put a little bit more time and effort into, is giving students the tools to be able to establish that SA before you hit the circuit.
Yeah, thanks, Neil. So a recurring theme here, as I understand it, is time is a critical issue. It takes time to progress through these different levels of right. SA, because pilots are, at least most of the time, less experienced pilots would take a bit longer to perceive the things that are around them. They might take a little bit longer to comprehend what's going on, and then to project ahead and come to the conclusion or the decisions that are necessary to be able to do that. Stefan, I might go to you. How does inadequate planning make building SA difficult? I've said it's been critical preparation prior to a particular flight, and planning is a part of that. If you haven't done that adequately, how does that lead to building SA? What makes it difficult?
Yeah, just continuing on from what Neil said so perfectly, if you don't have that plan in your head straight away of what you're going to do, it's just another item that you're adding to all your workload whilst you're flying and trying to focus on traffic around you and the environment around you. It's like you've got all these little boxes that you've got to tick whilst you fly, and let's say approaching an aerodrome, and you want to try and do that in a time efficient manner, but as soon as you start to fall behind, it just snowballs from there, and it makes it very difficult to start ticking all those boxes. So an example would be, quite often we'll go into a field with a student at 10 nautical miles. The student will do the inbound call, and then you might just ask, what's the overfly height for the aerodrome? And if the student doesn't know, because it's something that they should have planned probably whilst on the ground already, now they're shifting through the air, so looking for the overfly height. Whilst they're doing that, they're missing calls. They're not thinking about descending. They're not thinking about how they're going to join the circuit, which runway they're going to use. Is it left side? So all these little things just keep building up, and eventually you start to run out of time, which builds up on you very, very quickly, and you're almost overhead the field with not much of an idea what's going on around you. And it can lead to an incident, that snowballing effect. So if you don't have that item one ticked off in terms of the planning phase, it just allows you to really fall behind the aircraft and miss more boxes.
Yeah, thanks, Chris. Although I haven't got it there on the diagram, this recurring theme of time is certainly an issue. The more time is compressed for a pilot to build a good level of SA and come out with a reasonable decision at the end of it, which will provide a good outcome, the less likely that is to occur because of that compression of time. So it becomes a barrier, and I guess the other the likely result of that is the less time you have, the more your workload builds, and the less chance you've got of managing that. Chris, I might go to you. Do you think that learning good workload management skills is at least a part of the answer to developing a good SA, particularly at a busy, uncontrolled aerodrome?
Oh, 100%. That is a skill that we need to learn and maintain. There's a lot to do when flying. We often think we just turn up, jump in the airplane and go for a bit of a fly, and that's what flying's about. Actually, there's a lot more to it than that, and your instructor should be helping you develop and maintain a good workload management. and that enables you to spend more time having an overview and an overall assessment of what's happening around you and what's going on. So yeah, 100%. We need to encourage more instructors to focus on that, and not only is it a skill that we learn, but it's one that we need to maintain.
Yeah, that's a really good point, and because one of the points that I've got on the slide there in terms of building situational awareness is a lack of recency. So these things have got to be practiced over and over and over, and we do get very rusty or out of practice if we're not using those particular skills. And like anything else, if we're not using a skill, it tends to degrade over time, and we're not very good at it. So all of those things there are important, particularly the barriers there that are presented to us as we progress through this, model of building our SA. Stefan, I might ask you, in terms of directing a student or indeed a pilot on a flight review, in terms of their attention, do you find that you have to specifically aim at, getting them to notice something that might be happening around them? Do you have to get them to focus more on understanding what that means and then projecting ahead and to try and sort of verbalize the decisions that they come to from that point of view?
Yeah, yeah, definitely. It's very hard to do with flight reviews, because quite often students will come to you with a license. They might have been flying for years, but they would have really focused on flying in one particular area perhaps, or constantly practicing the items that they know very well, and trying to avoid the items that maybe they don't know so well. So even though, yeah, you've got pilots flying around with hundreds of hours, every time they do a flight review, you do definitely know certain standards have dropped and there is certain losses of situational awareness. So we try and cover that off as much as possible on the ground in that critical planning phase by trying to paint a picture of what we perceive might happen when we get to a particular, let's say, a non-controlled aerodrome. But yeah, you do have to all the time, going inbound, quite often the pilot's so focused on, meeting a standards in terms of flying the aircraft and handling the aircraft. One of the main ones is often, just missing calls basically, and painting a picture in their head in terms of what they think other aircraft might be doing in terms of how they're joining the circuit. And then also just bearing in mind, as a side note, if that other pilots don't do what they say they're going to do, or this whole plan that you've got in your head, we've mentioned this before, doesn't really go as you thought it would, what your following actions will be afterwards. So yeah, I think Chris mentioned before this whole tunnel vision thing, where you're so focused on one item, you might, sometimes students are so focused in that 10 nautical mile boundary that, they're looking at their fuel. Sometimes they're thinking too far ahead in terms of the forced landing. You might give them an hour from now, but they're not really focusing on the task at hand, and which is going to be the most critical safety point of the flight, which is how you're going to manage the traffic when you actually get into that circuit, and planning ahead of what you're going to do in certain scenarios should they unfold.
Yeah, some good points. Thanks, Stefan. In terms of things like decisions and making rational decisions from a good level of situational awareness, we've found over time, at least the ATSB have found in some of the research they've done with accidents that have happened in Australia, is that the more your time is compressed and the less you have of the time to come to a decision, generally speaking, the less rational it becomes, because your situational awareness has been degraded, and the less rational the decision is, the less chance you've got of a good outcome from the decisions that you make. So as we've said over the last 50 minutes or so, is when we progress through this level or this model of situational awareness, we need to build in some time, because it takes us time to do that. Now, the more experience we get, the more recent we are, the less fatigued, the better that we are at dividing our attention around it, focusing on different things, the better we manage our workload, the easier it will become to progress through those levels of SA and notice the things that are going on around us, immediately understanding what's required and what's happening, and then being able to easily project ahead and come to a decision about the things that we need to do. with our particular operation in relation to the traffic that might be around us. So that's Micah Ensley's level of situational awareness. As I said, been around for a long time, since 1988, generally accepted as the standard to look at in terms of, you know, having a think about the way you might progress through these different levels while you're operating an aircraft, or for that matter in any safety critical operation, like you know, managing or operating a nuclear power station, for example. They would go through all of these very same precise levels of building SA, and being a former air traffic controller, it is really quite important for ATCs to progress through these levels as well while they're in their job, to be able to gain the full picture in terms of the traffic that they're controlling. So this is really quite a critical process for people like air traffic controllers to progress through as well. Some psychologists say that through research, just for your information, sound is more likely to be responded to correctly when you're under stress or situations of high workload. In those types of situations, you're more likely to miss sighting or seeing something that might be critical for the operation of your aircraft. So, you know, if you need to rivet your attention, psychologists found that sound is more likely to do that, and that's why aircraft manufacturers build in things like audible alarms and warnings for things like aerodynamic stalling of the aircraft, to warn you that the aircraft is about to stall. A sound will go off along with all of the other characteristics that you might have in an aerodynamic stall. But if you're busy or you're stressed and you're in a high workload situation, that sound is more likely to grab your attention and focus it where it needs to be. And that's the whole one of the fundamental limitations of building SA. It's moving your attention around and focusing on the different tasks that you need to, and being able to do that effectively and efficiently. And it's a real constant process, and it requires constant practice to be able to do that, and that's where recency requirements are really quite important, and things like fatigue, making sure that you're fit for purpose in terms of operating your aircraft. Okay, so we've been going for just under an hour now, which brings us to the Q&A part of the presentation. I thank the panel members. So Landy, if I could ask you to change the settings, so if we have people out there would like to direct a question to a panel member or ask a general type question, if they would raise their hand first to be able to do that, and we'll take questions as best we can for the next 5 minutes or so, if we have them.
Hi Michael, microphones are now enabled. Thanks.
Thank you. So, folks, if you would like to ask a question, you can switch on your microphone now and direct it, or ask a general type question. I haven't seen any hands for the moment. Is somebody wanting to ask a question there?
Yeah, hello. One almost comment rather than a question.
Sure.
I've heard an example. It was an Australian bloke who theorised the grated cheese model of safety rather than the Swiss cheese model.
Well, that's interesting. I've never heard of that one before.
Oh,
yeah.
It came to me from a military pilot.
Okay.
So the grated cheese model is when you're holding the cheese against the grater.
Yeah.
Doesn't matter how much cheese is there, but you need cheese between the grater and your fingertips.
Yeah, for sure.
There can be a lot of cheese or a little bit of cheese, but when it gets down to no cheese, you get grated fingers.
Yeah. So you've lost your SA. So yeah, a good point. Like I said, one of the best ways I've seen SA sort of depicted is, you know, those slow rotating discs where you know, holes for just a brief period of time as the discs revolve sort of past one another, they line up, and that gives you that, you know, opportunity or a clear shot in terms of an accident. But grated cheese, yeah, I've not heard that one before. That's quite interesting.
Yeah,
Any other?
I think the example talked about that. There's times when your SA may be degraded, as you spoke about earlier, where you head down inside the cockpit. But before you go head down inside the cockpit, you make sure you've got like a 30 or a 60-second buffer between any threats before you go head down for 20 or 50 seconds in the cockpit.
Yeah, absolutely. Yeah, have a good look around first, and make sure there's like you said, nothing that's sort of confronting you over the next minute or so, so you can direct your attention and focus to other things momentarily, and that's a good part of the practice.
Yeah, it's an attention management skill to go, right, if I'm focusing on some calculations inside the cockpit, student using the WYSI wheel or something like that, if they get the calculation wrong because their head's outside the cockpit, then their error chain is just growing.
Absolutely, it does. And one of the things that we'll talk about in the series of uncontrolled aerodrome webinars next week is exactly those sorts of things that once we build SA might sort of degrade it and take it away from us. And one of those things is distraction or inappropriately lingering your focus around a particular task. And we've all seen the little clips that have been, the movie clips that have been made sort of to test people's attention with where we've got a gorilla that walks through the middle of a basketball team passing a ball. We have one in CASA on the hangar floor that we use sort of for engineers, maintenance engineers, but they all do the same sort of thing. They get you to focus and concentrate on a particular task, for example, and then while you're doing that, you're likely going to miss other things that are going on around you. So they make subtle changes to the information that you might be seeing. And because you're distracted away from that and you're focused on a particular task, it's quite likely that you'll miss the things that are going on around you. So some good points there. So it's all a matter of managing that and managing where your focus will be and your attention. Any other questions or comments?
I have a question. It's Carl Hughes. Can you hear me?
Hi, Carl. Yes, thank you. Go ahead.
I'm good. One question and a comment, please. I've noticed that in the time that I've been training over a fair while, that in the radio calls, initially we were told to say all stations, for example, all stations Lismore, and now that's traffic. I presume that was for a safety reason. Could you explain that?
Yep. Go on.
And the second part was what Neil said with respect to recreational aircraft, I presume, not having a radios. Is CASA doing something about encouraging people to have radios? It ought to not be too expensive to have some form of radio.
I can take your first question. Look, it's a part of the issue was standardising the broadcasting or harmonising with international standards. That's one of the reasons that sort of all stations went to traffic, and I guess another one of the reasons is all stations goes from 2 words down to traffic, which is 1 word. So it tries to make it a little more brief and I guess direct in terms of instead of saying all stations to be able to say traffic. So it's more of an executive word, if you know what I mean. It draws the attention of other pilots to your broadcast as soon as they hear that word traffic. So that's sort of generally the reasons that those changes were made. On your second point, look, CASA always encourages aircraft to be radio equipped. The majority of the Australian fleet is. There really wouldn't be all that many aircraft around that are not radio equipped, but some older aircraft that have been around for a long time, they might have trouble equipping aircraft like that with radio or comm systems, and as long as they are not operating within the vicinity of places like certified aerodromes or military aerodromes, they're not required to be radio equipped. But I think that the majority of the Australian fleet, in fact, are radio equipped. So you wouldn't come across a no radio aeroplane or aircraft all that often. I wouldn't think of in Australian operations.
Thank you very much.
No worries. All good. Any other comment or questions?
George here, if I can.
Hey, George, go ahead.
So your last comment about the radios, I honestly think that all the aircraft should be equipped with the radios. I've got in mind 3-channel radio, and the other important thing is to listen to the right frequency, and that's how you build your SA, listening what's happening around you.
Yep, absolutely.
And you get the picture. It's not necessarily approaching the aerodrome. It's just on trying on transit or wherever you're flying. Always listen to the right frequency.
Yeah, absolutely. Couldn't agree more.
And the other one, I've been criticized quite often that I use Aussie runways. That's another great tool because I can see other aircrafts and I can predict where they're going and I can make a radio contact and ask intention and all this. So I'm a big fan of those latest electronics availability tools we have. And really, I think all of us should be using them because that they are available to use it.
Yeah, thanks, George. Some good points, and I think there's nothing wrong with taking a handheld radio portable, for example, and monitoring the correct frequency, like George has said. So absolutely great. So look, folks, I think we'll finish it there. We've been going for just over an hour now, hour and 5 minutes. So thank you so much for your attention this morning, and don't forget about our 4th webinar coming up next Tuesday afternoon. It's an afternoon session, and that'll end the 4 series of uncontrolled aerodrome webinars that CASA have run. I hope you've enjoyed it. I hope you've got something out of it, and hopefully we'll see you again next week. All the best for now. Bye-bye.